Welcome to today's lesson. We are looking at squares and square roots. First of all, let us start with squares. We need to know what a square is, and for us to understand what a square is, we are simply going to find area of a square. Let's say I'm having this square and I'm required to find the area of a square. The sides of the square is 6 centimeters. So if I have a square of side 6 centimeters and I'm required to find its area of a square will be given by the side times side. So that means I'll have the area of this given square will be obtained by 6 times 6, which gives me 6 times 6 is 36. So this 36 is what is referred to as a square. So in this case, 36 is a square number. Alternatively, what we can do is we can demonstrate what a square is using dots. In that, if I'm having 6 dots, a row of 6 dots and a column of 6 dots, such that if this is my row for the 6 given dots, so we have a row and a column for 6 dots, then I fill up my spaces so that what I have is in form of a square. So we realize that the dots form up. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 6 rows of dots of 6, and we have 6 columns for the 6 dots. So if you find out in total what we have in this case, the row has 6, the column has 6. We want to find out in total what do we have. So we get that if I count these dots, I'll end up having 36. So what does it mean? A square is simply that number that is obtained or that is produced when a number is multiplied by itself. So when we multiply a number by itself, the figure we obtain is what is referred to as a square. So we simply get a square by multiplying the number by itself. So multiplying the number by itself twice, then it means whatever you've obtained is a square. So a number obtained So when you multiply a number by itself, then that digit that you are getting is what is known as a square. We've just looked at 6, and we've said that 6 times 6 will give us 36. The previous lesson we were looking at indices. And we said that if you want to write this number in index form, we simply count how many times has the number been repeated. And we discover that when we are multiplying a square, the number is repeated twice. So this number having been repeated twice, in short, I can simply write, instead of writing 6 times 6, I can simply write 6 to the power of 2. So when you are having any digit that is written to the power of 2, it simply means that you are going to get the square of that given digit. So 6 to the power of 2 simply means the same as 6 times 6, which will give me 36. So the symbol for a square, anytime you come across a number that has a power of 2, then it means we are getting the square of that given number. So we are just going to look at some few examples involving squares of numbers. So we have a sample of questions on the board that we are required to get their squares. So the first one I have is 5 squared. So 5 squared simply means that I'm having 5 times 5. And what is 5 times 5? 5 times 5, from our multiplication tables, we know that 5 times 5 gives us 25. The next number I have is 12 squared, and 12 squared simply means that I have 12 times 12. 12 times 12 will give me 144. The next number I have is 10 squared. 10 squared simply means that I have 10 times 10, and 10 times 10 gives us 100. Next, what I have is 8 squared. So it means I multiply my 8 by itself, that is 8 times 8. 8 times 8 gives us 64. Next, we have 11 squared, and 11 squared is simply 11 times 11, and 11 times 11 gives us 121. So we discover that we are finding the squares of the given numbers, and for us to obtain the squares of these numbers, we are simply multiplying the number by itself. 5 squared is 5 times 5, which gives us 25. 12 squared is 12 times 12, which is 144. 10 squared is 10 times 10, which is 100. Then 8 squared is 8 times 8, which gives us 64. And finally, 11 squared is 11 times 11, which gives us 121. So the second question asks us to write down the first 15 square numbers, one in index form and as a basic numeral. So you need to find out the index form of those given numbers and as a basic numeral. So I just want to put it in table form so that I have index form, and we have the basic numerals. So we are required to find the first 15 square numbers, one in index form and in basic, as a basic numeral. So the first 15 numbers as in index form, we have the first one is 1 squared, the second one is 2 squared, then we have 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, we have 10 squared, 11 squared, this is 12 squared, then 13 squared, 14 squared, and 15 squared. So those are the first 15 square numbers we have. So out of these, this is in index form as we've written. Then we need to write them as a basic numeral. So basic numeral simply means that we go ahead and multiply the number by itself and get the resultant answer. So when we have 1 times 1, it simply gives us 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, we have 16. 5 times 5 is 25. 6 times 6, we have 36. 7 times 7 is 49. 8 times 8, we have 64. 9 times 9 is 81. Then 10 times 10, we have 100. 11 times 11, we have 121. 12 times 12 gives us 144. Then we have 13 times 13 is 169. 14 times 14, we have 196. And 15 times 15, we have 225. So those are the first 15 square numbers we have in index form and as basic numerals. So when you are having the square, the power of 2 being written on the numbers, then that is in index form. But when you go ahead and simplify and get the resultant figure that is multiplied, the answer that is obtained when the figure is multiplied by itself, then that is written as a basic numeral. So we have index form of a number, then we have basic numerals. So these are basic numerals and these are index form. So after understanding that, squares is simply multiplying a number by itself. So if I have 2 times 2, then the answer I get is 4. So it means 4 is the square of 2. We need to find out now, how do we get square roots of numbers? So before we find the square roots of given numbers, we need to understand first what is a square root. And a square root is simply that number that when it is multiplied by itself will give us a square. So the number that you are multiplying by itself so that you get the square is whatever we are referring to as the square root. So in case, for instance, I'm having 2 times 2 to give me 4. 4 is the square. 4 is our square number. And 2, in this case, this is the 2 that I'm multiplying by itself. I'm multiplying 2 by itself. So this 2 is what is our square root number. So 2 is the square root number. The digit that you are multiplying by itself so that you obtain the square is what we are referring to as the square root. So what does it mean? If I need to obtain the square, I'll multiply a number by itself to get the square. But if I want to get the square root, then it means I have to get the opposite of the square. That digit that I'm multiplying by itself so that I get the square is what we are finding as the square root. So square root is simply the reverse of the square. So what you are doing to get the square, you will do the opposite so that you get back the square root. So how do we find square root of numbers? First, we need to know the symbol of a square root. Whenever you come across a question that has this symbol, then it means you are required to get the square root of that given number. So a symbol that appears in this manner refers to a square root of a number. So how do we get the square root? Let us find out how we get the square root using the following questions. So those are some of the questions we have and we are asked to evaluate. So as we are evaluating, what are we finding? The first part, we are finding the square root of 64. So in this case, our knowledge on prime factorization and prime decomposition is very much important. We need to find out what is the prime numbers that are composed in 64. So we need to get to know the prime factors that make up 64. So in this case, we had two alternatives when we are dealing with prime decomposition. We can either use the tree factor method or the factor tree method, or we can use the division method. So if I decide to use the division method, what do I have? So I have 64. We find out the prime factors that are making up 64. And to get our prime factors, then we need to have the divisibility test, the knowledge on divisibility tests. So we find out the first prime factor we have is 2. Is our number divisible by 2? And the answer is yes, because the last digit is 4. So since our last digit is 4, so 2 is the first prime factor we have. So we have 2 into 64, that is 32. Find out the next prime factor we have, and we get that 32 is still divisible by 2. So the next prime factor is still 2. 2 into 32 is 16. Next, we have the next prime number. 6 is our last digit, so it means that 2 is still our prime factor. So 2 into 16, we have 8. Then 8 is a is an even number. So being an even number, it means that our next prime factor is still 2. So 2 into 8, we have 4. 4 is also an even number. So 2 into 4, we have 2. And finally, 2 into 2, we have 1. So what is the prime decomposition of 64? Prime decomposition of 64, we have 2 being repeated 6 times. So our 2 is repeated 6 times. So I write it 2 times 2 times 2 times 2 times 2 times 2. This is our prime decomposition of 64. But what are we keeping in mind? We are not decomposing 64, but what we need to find is the square root of 64. So this is my prime numbers that are making up 64, prime factors that are making up 64. So I need to get the square root of these prime factors. How do I get the square root of these prime factors? You've discovered that we have 6, 2 has been repeated 6 times. So we can group, we are getting the square root, and we know that a square root is simply a number that is multiplied by itself. So that digit that is multiplied by itself is what is given as the square root. The digit that is multiplied by itself to give us the square is what is the square root. So I want to find out how many times do I have this number being multiplied by itself. So the first category where the number is being multiplied by itself is in the first group where I have 2 times 2. So it means in this case the square root of 2 times 2 is 2. The second case, I have the square root still of 2 times 2. So square root of 2 times 2 is still 2. Then the third case, I still have the 2 times 2 repeating itself. So it means that the square root in this case is 2. So it simply means that to get the square root of 64 will be obtained by the square root in each case, in each and every group. So this is the first group. Square root of 2 times 2 is 2. Square root of 2 times 2 is also 2. Square root of 2 times 2 is 2. So what does it mean? What is the square root of 64? Square root of 64 is simply 2 times 2 times 2. And 2 times 2 gives us 4. 4 times 2 gives us 8. So it means that the square root of 64 is 8. Part B, we are having 1,600 and we are required to get the square root of 1,600. So we find the prime factors of 1,600. So the prime factors of 1,600, the first prime factor we have is 2. 2 into 1,600 is 800. 2 into 800, we have 400. 2 into 400 is 200. 2 into 200, we have 100. So I have 100. 2 into 100 will be 50. 2 into 50, we have 25. Then the next prime factor we have is 5. 5 into 25 is 5. And finally 5 into 5 we have 1. So the prime decomposition factors of 1,600, we have 2 times 2 times 2 times 2 times 2 times 2 times 5 times 5. Then keep in mind we are finding the square root of 1,600. So I need to find the square roots in each case. So we find out square root is simply that number. When it is multiplied by itself, it will give us a square. So we find out how many times do we have the number appearing, multiplying by itself. So we get that we have 2 times 2, that is the first group. The second group, I have 2 times 2. Then I have another 2 times 2. And finally, I have 5 times 5. So what is the square root in this case? 2 times 2, my square root will be 2. 2 times 2, my square root is 2. 2 times 2, my square root is 2. And 5 times 5, my square root is 5. Then we go ahead and multiply these values. So it simply means that the square root of 1,600 will be 2 times 2, which is 4. 4 times 2 is 8. 8 times 5 is 40. So square root of 1,600 is simply 40. Next, we have 400. We need to get the square root of 400. So the prime factors of 400, we are starting all the way from 2. So I have 2 into 400 is 200. 2 into 200, we have 100. 2 into 100 is 50. 2 into 50, we have 25. Then next prime factor is 5. 5 into 25 is 5. Then 5 into 5, we have 1. So the prime factors making up 400, we have 2 times 2 times 2 times 2 times 5 times 5. So how do I get my square root? I group them into groups of repeated numbers. When I have the repeated numbers, then it means one of the numbers here, among the repeated numbers, one digit is our square root. So in each case, 2 times 2, the square root here is 2. 2 times 2, our square root is 2. 5 times 5, our square root is 5. Then we go ahead and multiply. So it means the square root of 400 will be obtained by 2 times 2 times 5. And 2 times 2 gives us 4. 4 times 5 gives us 20. So square root of 400 is simply 20. Next is square root of 81. So we need to get the square root of 81. We find out the prime factors making up 81. So our knowledge on divisibility test is still applicable. So we cannot start at 2 because we have an odd number as our last digit. It is not an even number. So the fact that we have an odd number as our last digit, it means that 2 is not one of the prime factors. So let us find out 3. If we take 8 plus 1 is 9. So 9 is a number that is divisible by 3. So meaning 81 is divisible by 3. So the first prime factor we have is 3. 3 into 81, 3 into 8, that is 2. Into 21, we have 7. The next prime factor is still 3 because 2 plus 7 gives us 9. 9 is still divisible by 3. So 27, 3 into 27, we have 9. Our next prime factor is still 3. 3 into 9, we have 3. And finally, 3 into 3, we have 1. So the prime factors making up 81, we have 3 repeating itself 4 times. So I have 3 times 3 times 3 times 3. So grouping them, we find that this is our first group of square. This is the other group of square. So from the number that is multiplying itself, we can simply obtain the square root. And we discover that 3 times 3, the number that is being multiplied by itself here is 3. So our square root in that case is 3. Our square root in this case is also 3. Then we remember that this is multiplication. So it simply means that the square root of 81 will be obtained by 3 times 3. And 3 times 3 is 9. So square root of 81 is simply 9. So the last number that we need to get its square root is 121. So we get the prime factors of 121. So our divisibility test, 2 is not a factor because this is an odd number. Let us find out, is 3 divisible by 3? So 3, we have 1 plus 2, that is 3 plus 1, it gives us 4. So 4 is not a number that is divisible by 3. So it means 3 is not divisible. We will not have 3 as our prime factor in this case. Let us get 4 is not a prime factor. 5 is the next prime factor, and for a number to be divisible by 5, the last digit should either be 0 or 5. But in this case, our last digit is 1, meaning this number is not divisible by 5. Next, we have 6. 6 is not a prime number. So the next prime number we have is 7. So far we do not have the divisibility test for 7, but we can just try and test. Is our number divisible by 7? 7 into 12, we have 7 into 12, that is 1. 1, we are having a remainder of 5 into 51, that is 7 because of 49, and we discover that we have a remainder. So it means that 7 is not a number to consider in that case. Then next we have 8. 8 is not a prime number, 9 is not a prime number, 10 is not a prime number, so we move on to 11. And for a number to be divisible by 11, we get the sum of the alternate digits, then subtract. So our alternate digits, we have 1 plus 1, which is 1 plus 1 is 2. Then this one has no other alternate digits, so it means it is only 2. So we have 2 minus 2, that is 0. So it means that this number is divisible by 11. So my first prime factor I have is 11. 11 into 121, 11 into 12, that is 1. Our balance is 1. So 11 is the number that is, 121 is divisible by 11. So 11 into 12, we have 1. We have a remainder of 1, so that makes this 11. 11 into 11, that is 1. So the next number is still 11. 11 into 11 is 1. So we get that the prime factors making up 121 is simply 11 times 11. But I'm looking for the square root of 121. So 11 has been multiplied by itself. It means that the square root is that number that is repeating itself. It is multiplying itself. So the number that is multiplying itself in this case is 11. So we get that the square root of 121 is 11. So after looking at the squares and square roots, we have situations whereby we will have problems that have combined the squares and the square roots. So we just want to look at some examples where we are asked to evaluate or to solve a sum that has both squares and square root, or the sum has various squares or various square roots combined together, so that you are required to work out the squares and square roots of those given sums that have several of them together. So example of the questions that have such like questions is this. We are told without using a calculator, evaluate the following. Without using a calculator, evaluate. So what are we evaluating? The first question that we are evaluating is 3 squared plus 5 squared minus the square root of 16. So 3 squared plus 5 squared minus the square root of 16. So what do? We first try and simplify. 3 squared simply means we have 3 times 3. 5 squared means that we have 5 times 5. Then the square root of 16 simply means that there is a number that when it is multiplied by itself, it will give us 16. And we know that from our multiplication tables that if I have 4 times 4 will give us 16. So this means that the digit that we are supposed to get the square root, in this case, our square root is simply 4. Then 5 times 5 gives us 25. And 3 times 3 gives us 9. So I have 9 plus 25 minus 4. So after that, we simplify. So we have addition. So we add first, then subtract. So 9 plus 25 is 34 minus 4. 34 minus 4 is 30. So we have our answer as 30. Next, we have 1 squared times 2 squared times 5 squared. So in that case, we have two ways in which we can solve this given sum. So the first way is I simplify what I have first, so that I have 1 times 1, then multiplied by 2 times 2, then multiplied by 5 times 5. So this gives us 1 times 1 is 1, 2 times 2 is 4, and 5 times 5 is 25. Then next, 1 times 4 is 4, then multiplied by 25. 4 times 25 gives us 100. That is one of the options I can opt for. Alternatively, what we can do is you can have the square in brackets, in that I can decide to multiply first the numbers I have, that is 1 times 2 times 5, but I have my square covered outside that given bracket. So if the square is outside the given bracket, then it means I first simplify what is inside the bracket, then I'll go ahead and get what I'm required to do after the brackets. So what is this? This is 1 times 2 times 5. 1 times 2 is 2. Then we have 2 times 5, which will give us 10. So 2 times 5 is 10. So next we have 10 squared. So 10 squared is simply 10 times 10. And 10 times 10 is 100. So we discover whichever method you opt for, it will still give you the same answer. So what does it do? It brings us to this conclusion. If you are having a number, a squared multiplied by b squared, it is simply the same as a times b in brackets squared. So if you have a squared times b squared, it is just the same as, you can simply take the numbers, multiply them first, then the answer you obtain, you get the square of that given answer. So a squared times b squared is the same as a times b in brackets squared. Another sum that we are required to simplify is 5 squared minus 3 squared. Then we have the square root on the two figures. So simplifying first what is inside the bracket, I have 5 squared, which is 5 times 5, then minus 3 squared is simply 3 times 3. So this means 5 times 5 will give us 25, minus 3 times 3 will give us 9. Keeping in mind, we are getting the square root of our working. So the square root sign, we shouldn't forget it. So 25 minus 9 is 16. So the square root of 16 from our working previously, 16 is simply 4 times 4. So 4 times 4 will give us 16. So it means that the square root of 16 is 4. So our required answer in that case is 4. Next, we have the square root of 9 times the square root of 64. Square root of 9 is 3. Square root of 64 is 8. So this is simply 3 multiplied by 8, and 3 times 8 gives us 24. Alternatively, what we can do is we can start by multiplying whatever is inside the square root, such that I have 9 times 64. Then after that, I get the square root of that. So 9 times 64 from our multiplication algorithm simply means that 9 times 4 is 36. Then 6 times, we write 6, carry 3. 6 times 9 is 54. 54 plus 3, we have 57. So we have 576. So 9 times 64 simply means that we are getting the square root of 576. So getting the square root of this given number, we've already looked at options in how we can get the square root of that given number. So we find the prime factors making up 576. So the prime factors making up 576, the first prime factor is 2. 2 into 5, that is 2. We are left with 1, so this makes it 17. 2 into 17, that is 8. We are left with 1, so this makes it 16. 2 into 16 is 8. Next prime factor is 2. 2 into 2, that is 1. 2 into 8, 4. 2 into 8 is another 4. Then we have 2. 2 into 144, that is into 14. 7 into 4, 2. 2 into 72, we have 2 into 7, 3. 2 into 12, that is 4. No, 2 into 12, 6. Next is still 2. So 2 into 36 is 18. 2 into 18, we have 9. So the next prime factor we have is 3. 3 into 9, that is 3. And finally, 3 into 3, we have 1. So the prime decomposition, or the prime factors making up 276, we have 2 repeating itself 6 times and 3 repeating itself twice. So we have 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3. I need to get the square root, so it means that I group them into groups that have a number multiplying by itself. So in this case, my square root is 2. In this case, my square root is 2. Here, my square root is also 2. Then 3 times 3, my square root is 3. So this means that I have 2 times 2, which is 4. 4 times 2, that is 8. 8 times 3, we have 24. So we get that this answer and this one is the same. So whichever method you will opt for, you can either start by multiplying the numbers inside the square root, then after that, get the square root of your product. So this brings us to another conclusion, that if I have a square root of a number A multiplied by a square root of a number B, it simply means that I can get the square root of the product A times B. So we can just have the product A times B and get the square root of that given product. So 100 minus 64 over 9, we are getting the square root of our calculation. So I start by simplifying what I have inside the square root sign. So inside the square root sign, I have on the numerator, I have 100 minus 64. So 100 minus 64 is 36. Then divide by 9. After I've divided, I need to get the square root of that given sum. So 36 divided by 9 is 4. So the square root of 4 is simply 2, whereby 4 is just 2 times 2. So it means the number that is repeating itself in this multiplication is 2. So the square root of 4 is 2. That is the first option after I've simplified the subtraction sign. I can go ahead and divide first, then get the square root. Alternatively, I can decide to get the square root of the numerator, that is the square root of 36, get the square root of 9, then divide later on. Square root of 36 is 6. Square root of 9 is 3. 6 divided by 3 is 2. So whichever option you opt for, it means it still gives you the same answer. So in that, what does it mean? It gives me another conclusion to make. In that, if I have the square root of A over B, then it is the same as the square root of the numerator A divided by the square root of the denominator B. So it means that A over B, the square root of A over B is the same as the square root of A divided by the square root of B. So I have 333. I'm supposed to get the square root of the sum 333 plus 196. So we have 333 plus 196. So I have 333. I'm adding 196. So when we are adding, we start from the far right. So I have 3 plus 6, that is 9. 3 plus 9 is 12. We write 2, carry 1. So 1 plus 3, 4. 4 plus 1, we have 5. So 333 plus 196 gives us 529. I need to get the square root of this because that is what the question is requiring me to find. The square root of 529. So we find out using our division. So if I have 529, I need to find out which factors we are making up 529. So the prime factors, 2 is not a prime factor making up 529. Why? 9 is an odd number. Next, we have 4 is not a prime number. 3, we have 3. If we add, this is 7. 7 plus 9 is 16. 16 is not a number that is divisible by 3. Then next we have 5. Our last digit is neither 0 nor 5, so we cannot use 5. We have which other number from 5? 7. Let us find out if 7 is divisible by this number. So 7 into 52, that is 7 because of 49. 49 from 52, we have 3 into 39, that is 5 because of 35. So we have a remainder. So it means that 7 is not a number that we are looking for. Another number from 7, 9 is not, 8 is not a prime number, 9 is not a prime number, 10 is not a prime number. We are moving on to 11. And 11, 5 plus 9 is 14. Then minus 2, 14 minus 2, the sum of the alternate digits, then we get the difference. So we have 14 minus 2 is 12, and 12 is not a multiple of 11, so it means this number is not divisible by 11. So it means that I've tried all the divisibility tests we know. We have divisibility tests all the way from 2 to 11. So what does it mean? Since it doesn't lie in any of the digits that I'm left with, then I need to get the square root using other means. Either I can try out those other numbers, or you can use a calculator to find out what is, no, but our question was we are not supposed to use a calculator. So that means I'm supposed to get those other prime numbers that are after 11, because our divisibility test goes all the way to 11 only. So other prime numbers after 11. The next prime number after 11 is 13. Let us find out, is this number divisible by 13? So if I have 13 as my number, 13 into 52 is 4 times. So 4 times 13 is 52. So that means 13 into 9 is 0. So we find that we have a remainder of 9. So 13 is not the prime number I'm looking for. The next prime number that we have after 13 is 17. Let us find out if this number is divisible by 17. So 17 into 52, So I have 17 into 52, that is 3 times 3 because of 51. So 51, it means that I'm having a remainder of 1, which makes this 19. 17 into 19 is 1. And we have a remainder of 2. So it means that 17 is still not the number I'm looking for. After 17, the next number is 19. So 19 into 52 is 2 times. So 19, let's say 19 times 3 is 27, 57. So 19 times 2 is 36. So 19 into 52, that is 30 twice because of 36. Then I have a remainder of 16 into 169. So I have 19. Let's see, times 8, we have 72 carry 5, 72, we write 2 carry 7, that is 15, so 152. This is 7, 1. So we get that we still have a remainder of 17. So meaning 19 is not the number I'm looking for. 20, 21 is not a prime number, 22 is not a prime number, so we are left with 23. So the next number I have is 23. So the next prime number, 23 into 52, 23 into 52, that is 2 because of 46. 52 minus 46, we are left with 6. 23 into 69 is 3 times. So we find that 23 is the next prime number that I'm looking for. So 23 into 529 is 23 times. So it means the next prime number is still 23. So that 23 into 23, we have 1. So this means that 529 is simply 23 times 23. So what is my square root? The number that is multiplying by itself in this case is 23. So the square root of 529 is 23. So in concluding this, we just come up with, we find out these properties of square roots and try and prove, do they work or they don't work? So we have the properties of square roots. Properties of square roots. The first property of square root we have, and we need to prove if it is working or not, is this, that if I have the square root of A plus the square root of B is equal to A plus B square root, we need to find out, does it really work or is this not a fact? So let us find out. For instance, if I have, I'm using an example, quite a quick example for us to understand. If I have the square root of 9 and I have the square root of 16, is this the same as this? So let us simplify on this side. Square root of 9 is 3. Square root of 16 is 4. Square root of 9 is 3, square root of 16 is 4. So we get that square root of 9 plus square root of 16 will be 3 plus 4, which gives us 7. But in this case, if I have 9 plus 16, then I get the square root. 9 plus 16, getting the square root, simply means that 16 plus 9 will give me 25. 25, square root of 25 is 5. So what does it mean? That this one is not equal to this. So don't assume when you are given a sum that you have to get the square root of one number, add the square roots, Don't assume that you will go ahead and add those square roots and simply get the square root of the answer. You will have used a wrong method. So when you are having addition, what do we mean? We first simplify, get the square root of the first number, get the square root of the second number, then go ahead and get the answer. So if you use this, then it means that this one is not true. The second property of square root that we need to confirm is this. This was addition. So let us work it out with multiplication and find out, are they the same or are they different? So if I have square root of A times square root of B, find out if it is the same as A times B, square root of the product A times B. So we are still using the same numbers we had, that is square root of 9 and square root of 16. Square root of 9 is 3, square root of 16 is 4, so 3 times 4 is 12. Then in this case, we are using this formula. Let us find out. This is the same as 9 times 16, then we get the square root. So what is 16 times 9? 16 times 9 is simply 9 times 6 will give me 54, carry 5, so 54 plus 5 plus 9, because 1 times 9 is 9, plus 5 that we had carried, we are getting 14. So we get that here we have the square root of 144, and the square root of 144 is simply 12. So we get that this one is true. It is acceptable. You can either start by multiplying the number inside the bracket first, then go ahead and get the square root. Or you can get the square root first and multiply the square roots that you've obtained. So if you use this method or this one, it is still acceptable. We have the square root of A squared. Square root of A squared simply that we are saying that the square root of A squared is the same as simply A. So if you have the square root of A squared and you just try and ignore the squares that are here and get the figure that you have, what does it mean? If I have to simplify this and find out, is this equal to that? So that I have square root of A squared is the same as A times A. And A times A, this is A squared. A squared is A times A. Then I need to get the square root of A times A. So it means that the square root of A times A, I simply pick 1 out of the 2, because this is a number that has multiplied itself. So it means that the square root of A squared is simply A. So this means that that one is true. For instance, if I'm having to get the square root of 3 squared, and I say instead of going into those calculations, I simply say that the square root of 3 squared is 3. It is true, because 3 squared is 3 times 3, then the square root of 3 times 3 is 3. So that means that a square root of A squared is 3. So those are some of the properties of square roots that can be used in calculating square roots of given numbers. So it is important to note that a square is that number that is obtained when a number is multiplied by itself. A square root is the number that is multiplying itself to give us the square. So that digit that you are multiplying itself to get the square is what we are referring to as the square root. So be very careful to find out. There are the two signs. We have the sign for the square is that the number will be written with a power of 2. The sign for the square root is that. So this is referring to square root. Then this is a number that has a power of 2. So a number with a power of 2 will mean square. The other sign is simply referring to the square root. So concentrate on the question very well. Find out, what are you required to find? Are you required to find the square, or are you required to find the square root? Thank you.